All right, so we are on, still on the 7.1 packet. Okay, you can see what we did yesterday. We're going to keep going, but now our square roots are already going to be multiplied by something. Okay, so we talked about perfect squares. Well, here I have a perfect square here. See, 121 was right there. Okay, 121, look, 10 squared was 100, so we know that's 11 squared. Okay, so I know the square root of 121 equals 11. Without the square root. We took the square root of that and we got 11. But I still have this 2 out front. So I really have 2 times 11 and I get 22. Okay? Well, here, 289. I only had to list 12 perfect squares there. So if you don't know the perfect square of 289, try this. Well, use your calculator. Okay, square root of 289. If it's a perfect square, you will get a whole number answer. So this was. So really, I can replace 289 with 17. Okay, no more square root because I took the square root of that, so it's gone. And you take 17 times 6, and you get 102. Okay? Now, if we take the square root of, well, we know up here that 100 is a square root. We know that 4 is a square root. So obviously, square root of 400 is a perfect square. I'm sorry, those were perfect squares. So I could take, let's see, I still have the 3 out front. Don't forget it. Square root of 400, let's see, square root of 4 was 2. Square root of 100 is 10. So really, you're multiplying those together. So you have really a 2 times 10 if you have to do it that way, or replace it with 20. 2 times 10, okay? So let's see, that ends up being 60. All right? So that was just when we can take nice, pretty, perfect squares, make it a little easier without having to use the calculator unless you get big ones, okay? But if you can use your list here, hopefully you can remember, because 4 is 2 squared. 9 is 3 squared, 4 squared. You could list those under there so you easily know square root of it will be 4. Square root of 25 would be 5 because it's 5 squared, okay? But let's go down and look at number 10. I'm going to zoom in a little bit. Maybe you can see a little better. All right, so I have this 2 out front. Now I'm going to simplify the square root of 54 the way we simplified yesterday. So I'm going to do a little tree. But when I deal with the square root answer at the end, I know I have this 2 out front, and I don't want to forget it. So I'm kind of going to write that just like that to start with, so I don't forget those parts. Now, 54 is even, so I know 2 goes into that. That's always the first thing I look for. Is it even, or does it end in a 5? Because then you'd take a 5 out. Those are the easiest ones. Take 2 or 5 to start with. If neither of those go in, then try 3 and so forth, okay? But remember, prime numbers are 2, 3, 5, 7, 11, 13. Those numbers that only 1 times itself can equal, okay? All right, so if I divide that by 2, let's see, I get 27. Well, that's not even, doesn't end in a 5, but let's see, I can divide that by 3. I know 3 times 9 is 27. 3 is prime, 9 is not, so take 3 times 3 is 9. Now these are all prime. These are done for because I already divided them. Okay? So I circle any pair. Well, you could circle these 2 3s or you could circle these 3s. It doesn't matter. Just I need to circle 2 of them. This doesn't have a pair and this one doesn't have a pair. So outside the radical, I'm going to write the number 3, so it's times 3. Inside the radical, I write this 2. And I write this 3. Remember, everything is multiplying, okay? We already had this 2 out front. That's where that one came from, okay? This 2 came from the fact it did not have a pair when I did the prime factorization. So 2 times 3 is 6. I still have a square root. 2 times 3 is 6. Okay? So 2 square root of 54 equals 6 square root of 6. All right, turn the page. All right, oops, sorry, my page is weird here. All right. Now we still have this -5 out front, so I'm going to make sure I have that -5, and I'm going to have a square root. I don't want to forget about that. That's the most common problem when we're simplifying radicals that are being multiplied by something. People forget that thing that's out front already. So, but when we simplify, when we do our little, I call this the factor tree because we're finding that prime factorization, making branches. I kind of ignore that -5. That's why I bring it over and put it where I'm going to be writing my answer. Okay, so 150, well, it's even, so a 2 goes into it. Okay, let's see, 2 would be 75. Okay, not even, so 2 doesn't go into it, but 5 does because it ends in a 5. So I'm going to take out a 5. Okay, and I get 75 divided by 5 would be 15. Okay, well, 3 goes into 15 5 times. So now we circle our pairs. Well, here's a pair of 5s. They are not right by each other, but there's a pair of them. This one doesn't have a pair, and this 3 doesn't have a pair. So outside goes the pair, so I write that number 1 time on the outside. Remember that -5 is from the problem itself. But then I have a 2 and a 3 that don't have a pair, so I write those inside my radical. -5 times 5 is a -25. 2 times 3 is 6, would still be inside the radical. I'm going to get a different marker. My marker's dying here. But, so, -5 square root of 150 equals -25 square root of 6. That's as simplified as it gets. Okay? Now number 12 has an 8 out front, so write your answer with an 8. And we're going to have square root. I may have to write my other problems in front. I kind of wrote that a little close, but that's okay. So let's do our factor tree to the 128. It's even, so 2 goes into it 64 times. Okay, 2 is prime, 64 is not. So I got to take the prime number out of 64, and let's see, it's even again, so 2, and I end up with 32. Well, that's not prime, so 2 goes out of that 16 times. Whew, still not prime. 2 goes out of that 8 times. This one's going to be a long one. 8's not prime, so you get 2 times 4. 4 is not prime, which is 2 times 2. So all of these were not primes, but all of these that I ended up with is the prime factorization. So let's circle every pair of 2's. There's a pair of 2's. There's a pair of 2's. There's a pair of 2's, and I'm left with this little 2 left over. So I have 1, 2, 3 pairs of 2's. So I got to write these on the outside, and I'm just going to put them in front here. Okay, I wrote down those 2's, and then I have 1 left on the inside. All right, so for the outside, you have 2 times 2 times 2 times 8, which is 64. And you're going to have a square root of 2. All right? So let's try it on number 13. Okay, so -3 times the square root of 28. So we're going to have a -3 out here. I wrote it close again, but that's okay. I can write the other things in front. 28. Let's see. It's not. It is even, so take out a 2 and we get 14. And that'd be 2 times 7. And 7's prime, so I can't do anything else. Here's a pair of 2's. So I have to multiply that front by 2. This one doesn't have a pair, so I write it inside. 2 times -3 is -6, and I have square root of 7. Okay, so -3 times square root of 28 is -6 square root of 7. All right, and let's do 14. And again, it's like blending here, so I'm going to change colors so I don't blend into that one here. All right. I'm gonna actually move it and write it over here on the side because I don't want to blend into stuff we're going to do later. So I have 4 square root of 384. Okay, well, I'm just going to do the square root. So remember, my answer is going to have a 4 and going to have a square root of 3. No, it's not. I don't know what's in the square root yet. I don't know what I'm writing. Okay, sorry about that. All right, it's even, so I know 2 goes into it. Let's see, 192 times. Okay, 192 is even, so 2 comes out of it. I divide it, I get, what did I do? 96. Okay, 2 goes into that. 48 times. 2 goes into that. 24 times. 2 goes into 24 12 times. 2 goes into 12 6 times. And 2 goes into 6 3 times. Whew, that was a lot. Glad I did it down the side there. Okay, so here's a pair of 2's, a pair of 2's, a pair of 2's, and then this 2 and this 3, oops, don't have a pair. Alright, so I have 1, 2, 3 pairs of 2's. So on the outside I have 3 2's. Inside I have these. I have a 2 and a 3. Okay, so 4 times 2 times 2 times 2 is 32. Square root of 2 times 3, which is 6. Alright, so go on to the next page. Okay, we're going to kind of stop the lesson part there, but for the rest of the class, I want you to do 2, 3, 7, 8, 9, 10, and 11. Okay, and then you'll submit a picture of those, let's see, 2, 4, 8 problems. No, I can't count. 7 problems. Okay, you'll turn in a picture of those completed 7 problems. And I know we haven't done these last 6 yet, but that's fine. So stop the lesson there, submit that into Canvas, and you are done for the day.